Everyone. So today I will do yesterday's lit code question because I skipped it yesterday because I went somewhere during the weekend. Okay, let's see the question. I'm reading this question for the first time, so let's solve together. 1472. Design browser history. You have a browser of one type where you start on the home page and you can visit another URL, get back in the history number of steps, or move forward in the history number of steps. Okay, so it means that I only have a browser of one type, and I can go from I can home page URL to another URL, right? So another URL will have another type, like it will have a different type, and another URL and another URL. So and this saying that you can visit another URL, get back in the history number of steps. So I think it means that if I am at some URL, then I can get back in the history number of steps. So if I can go back the 2 steps back, or I can go forward 2 steps forward, like that. Okay, and implement the browser history class. So the browser history have these functions. Browser history homepage initializes the object with the homepage of the browser. So this is for the initialization, like a constructor initializes the object with the homepage of the browser. Okay, so first of all, this is a base. No, so whenever I'm creating a here in explanation, whenever I'm creating a new browser history, then I will pass some URL which will be the homepage of the homepage URL, and right, initialize the object with the homepage of the browser. Initializes the object with the homepage of the browser. Okay, so whatever I pass will be the homepage of the browser. In this question, litcode.com will be the homepage of the browser. Okay, and void visit your string URL. This will we can visit URL from the current page. Okay, so if I'm in this page right now, so I am writing I for the current. So if I have reached here, and if I want to visit, suppose google.com, then I can just call visit URL, right? So browserhistory.visit google.com, then you are in litcode.com and visit google.com. Okay, so I'm just looking at this example here, and it will be like, so first of all, the browser history will be created with litcode.com, and then I'm visiting google.com, right? So it means that from litcode.com I'm visiting google.com, and then so that is what visiting. So here is another call again. So from google.com I'm visiting facebook.com and youtube.com as well, youtube.com. Okay, so what is back now? Back is being called. So back number of steps is 1 here, and if I call back number of steps, then I can move steps back in history. Okay, so if you can return x steps in the history, steps is greater than x, you will return only x steps. Return the current URL after moving back in history at most steps. Return the current URL after moving back in history at most. Okay, I think that what this is saying is, so if I say browser history.back 1, then I according to this one, the latest URL that I visited is youtube.com, right? So if I say back 1, then it must, because I'm only going, because this is a browser history, so this is the most recent one, right? If I'm just going 1 step back, then it is facebook.com. It should return facebook.com. Oh yeah, you are in youtube.com and move back to facebook.com and return. So whichever step I go back to, it will return that steps URL. Okay, and what this is saying is, if steps is greater than x, you can if you can only return x steps in history. Okay, so what this is saying is how many steps I can return. I can return 1, 2. If the back was 2 steps, then it would return this. If the back was 3 steps, then this would be returned. But so it means that x is equal to 3, right? I can only return x steps, 3 steps. But what if I but what if this was 4 instead of 1? Then what would I do? Then in that case I would only return x steps. Okay, so it means that if the uh, if the number of steps is greater than the at most steps, then I'll return the URL at most steps, right? Because here at most steps is x is equal to at most steps is equal to 3. Okay, this is the at most step where I can go to. If it is greater than at most steps, then I'll just return in this only. And forward also, move steps forward in the history. Okay, so if I see, then I'm just looking at this one. So when I'm going back 1 step, then it will reach here, and again back 1 step, then it will reach at google.com, right? Now it is calling forward. So what would happen when we are calling forward? So forward in steps, so move steps forward in history. So it means that from this position, we are at this position, right, until this call. Okay, sorry, until this call we are at until this one we are at google.com. And if I'm calling forward 1, then I think it should go here, right? If it is calling forward 2, then it should go here. But what if it is calling forward 3? So at most forward steps each just 2 here, because I can only go 2 steps forward. If you can return x steps in history and steps is greater than x, suppose if steps is equal to 3 and 3 is greater than 2, right? So then you will only return x steps. So it means that I'd only if someone is telling me to go 3 steps forward, but I can only go 2 steps forward, right? So I will just return wherever I reach at 2 steps, and return the current URL after forwarding in history at most steps. Okay, what is this thing? I think I'm clear about everything, but what is this? It clears up all the forward history. Visits URL from current page. Oh, okay, got it. So it means that forward 1, I reached to facebook.com because I was at google.com, and if I just do forward 1, then I would go to facebook.com. But from facebook.com, I am visiting linkedin.com, right? So it means that what this is saying is I can visit URL from the current page. So LinkedIn would be this one, linkedin.com, because from the current page I visited linkedin.com, right? So it means after this will come. So where will youtube.com go? It is saying that it clears up all the forward history. So it means that, according to my understanding, it clears up all the forward history. So it means that all the forward history will be deleted. Everything, if there was other URL also, then everything would be deleted. Okay, I think that's what it is meaning. So if I visit this, then whenever I'm visiting, then what should it return? It only returns null. Okay, whenever we are visiting, then it returns null only, but we are not returning anything else. Only when we are going back or forward, we are returning URL. Okay, and this is visit. After visit, we are doing forward 2. Okay, but you cannot move. Oh yeah, right, that's what I was thinking, because we are already at the at the edge of this history, and we cannot move anything. There is nothing forward. So I think that this should return linkedin.com only, right? Yeah, this return linkedin.com only. And when I'm going back, then it should return google.com. right? Okay, yeah. Now when I'm going back 7, then it should return, because I can only go back one step, but it is saying that this person who is calling this, they want to go to 7 steps back, but I can only go one step back. So I will return whatever I can. So I'll return litco.com only. Okay, yeah, that was pretty straightforward. Now let's see constraints. Homepage.length. So homepage.length will at least be 1. Oh my god. Okay. It means that homepage.length, uh where you can use the, so it means that I can pass anything here. It is an array. Homepage is an array. Oh, it is in string homepage. But why is it saying that homepage.length? Oh, okay. Oh my, why it is just saying that homepage is string length. I was thinking that homepage is an array and then I can pass any array here. But no, it's just that homepage will be at least uh will at least have one character. It can go up to 20 character, right? Because it is a string, not an array. And url.length, it will also be not be empty, it will at least be 1. Steps is also there can be from 1 to 100, so there will not be a negative step or 0 step. Okay. And homepage and url consist of dot and lowercase english letters, right? So it will be facebook.com, there will be one dot always, and lowercase english letters. Okay. And at most 50,000 calls will be made to visit back and forward. Okay. This is a very interesting question. I have not thought of solution yet. I was just thinking of understanding the problem, which I did, I think. Let's think about the approach. What approach can I take to solve this? To do, yeah. And I should think of optimal solution, but before that, let's think of brute force, because thinking brute force will help me to come to optimal solution. And I'm checking the time; it is 6:37 p.m. I need to uh, complete this question very quickly because my friends are coming soon. So, okay, let's think about the approach. Approach. For the home page, it is pretty simple. I just need to this thought. What I was thinking was like whenever I drew this, whenever I wrote this example, I wrote it as a linked list. So I don't know, like linked list is in my mind in the beginning, but let's see. So browser history function home page. So first of all, the home page will be just like this dot start or something, this dot head or something. It will be a home page, and this dot head will be a home page. I'm just like, this might be a linked list or something. Okay, I'm just saying that head will be a home page, so there will be something here and it will be a home page. And after that, I need to visit, right? So whenever I'm visiting, it is like litco.com. Whenever I'm visiting, so if home page is a lead code, then I need to attach it, right? So if this is current, then I need to attach Google now. And if I'm visiting again, then I need to attach Facebook again. Okay. Attaching is done. Visiting is a simple, like I can use either array or linked list or anything. But how can I go back and forward easily? So after Facebook, I will go to YouTube, and so it means that my current pointer will be at this point, YouTube. So how can I go backwards? Because if it is a single linked list, then I cannot go back, right? If it is a doubly linked list, then I can go back. I think that I have never done a problem which solution is a doubly linked list. Or what I could do is I could just store here. Yeah, the doubly linked list also might work, because doubly linked list is just, we are just storing previous, right? In singly linked list we were storing next, but in doubly linked list we are also storing previous. So that is also one way. If I have a previous and next for every node, for every value, then that would be easier, right? So if I'm at YouTube and if I want to go back one step, then if this has previous, then I will just go to, okay, I can just say that, okay, this is my value, and I could just return Facebook. And if I want to go back, then I can just use previous again of Facebook. Facebook's previous is Google, and then back. And then if I want to go forward, then I can just use next of this one, and then okay, Google's next is Facebook, and Facebook, and there's visit again. Okay, so this is the current and I want to visit, right? So I can just add I can just update its uh next to LinkedIn. So if I just update it, then all the other what can I say, all the other next values would be cleared, like the question is saying. It clears up all the forward history, so that this is perfect. I think I can go back or forward. Yeah. So if I'm going back and forward, then I can just use a linear traversal, right? So if I'm at current here, and if I want to go 2 steps back, then I will go 1 2, like I can just use while loop or something, and I can traverse linearly back, right? Back 2 times. And if I'm going backward, if this is the head, then I will just return the head value only. While going back, if I encounter the head, then it means that I cannot, there is nothing, right? I mean, head's previous will be null. So if there is nothing, then I'll just return this. And if I'm going forward, uh, but the current value is null, then it means that I can only go until this value. I've reached the utmost step, so I return the current value. Okay, I think this is a good solution. So the time complexity would be O of n for going back and forward, and the yeah, O of n, where n is the number of values till now, right? So yes, is there an optimal solution to this? Is there an optimal solution? I think that because we are just going back, we are going backward and forward. So if we are going back and forth, right? If I'm at some value, then I need to go to the back and forth. So there should always be some, even if I use a hash map, then it should be Google, then I need to know what is in the, what is at, what is there after 1 step, what is there after 2 step, what is there after 3 step. I need to know immediately. So if I'm using linked list, then I need to do that linearly. But is there any data structure or anything where I can do it instantly? Of course there is a array also, right? So if I am just using array, then it would be this would be a 0th index, and this would be at 1, this would be 2, this would be 3. And if I want to return after 2 steps, suppose if I'm currently at Google, and if I want to return after, if I want to return, if I want to go back, or if I want to go forward 2 steps, then I can just do 1 plus 2 is equal to 3, right? And update current to this one. So that will just take me going back and forward would take me of 1 time if I'm using an array. But what about visiting? because if I'm visiting, then I need to insert it, right? So suppose current is at Google, and I would say that I'm at Google and I want to visit suppose Instagram. Then then everything should be clear, right? All everything should be clear, and this would have been phrase. This would be phrase. So to do this, I should what I should do is I need to insert Instagram at the next position, Google's next position. Like I need to insert Instagram at array 2. Array 2 will be Instagram, and then all everything should be popped. So that would take off and time, right? Because there might be n elements after this one, so it would take off and time. In worst case, it would take off and time, because I need to pop everything after Instagram. Yeah. So visiting in visit function in array, I mean in linked list, takes smaller time, but visit function in. Is there any follow-up question or something where time constraint is written? I'm thinking that I might use so until now what we got is, if we're using array, back forward is 1, and visit it of n time. And if using linked list, then back forward is of n, because I need to traverse, and visit would just take of 1 time, because it is like insertion. So this is a typical question. So this is a insertion. For insertion, when you're using linked list, it would only take this time, right? But using array, it would take a much longer time. This is an insertion, and this is a access. We are just accessing this, and for accessing, it would take of n time. Yeah. What can I do then? I'm just calibrating. Okay. Okay. So what can I do? One is linked list, 2 is array. So approach is, one is using linked list. This is the runtime. Another is array. This is the runtime. Can I make back forward and visit both in a single time? Okay, what constant time? Can I do both in a constant time? That is my question right now. Can I use them, like, is there a way where I can use both of these together? Maybe I can make a use of fast map and say that, okay, lead code. Okay, at 0th position, so I would use linked list, but lead code, and 1 is at Google, and at 2th position Instagram, at 3rd position 3rd position Facebook, and at 4th position LinkedIn. So whenever I am I'm saying that, okay, I'm using a linked list as a primary data structure, okay, and there is no array. I'm not using an array. So this is a, I'm just thinking of the thought approach, use of linked list and as map. I'm not sure if it is if it works or not, whatever I'm thinking. Okay, what I was thinking is, first of all, if I am here at Facebook, then if I'm at Facebook, then I need to know at which position Facebook is. So suppose I know that Facebook is at third position, and then if I want to go back 2 steps, then right, if current is at third position 0 3, then going back would be just 3 minus 2 equals to 0 1 2. Sorry, Facebook is at 2 step, then oh, what am I doing here? So if Facebook is at this step, and if I want to go back 2 steps, then it would be 3 minus 2 is equal to 1. So what is that 1? Google, right? So that's great. So if I'm using a hash map with linked list, then this problem would be solved. Back and forward, I can just access it in of one time. But main thing is, how can I update this hash map after I visit? So suppose if I'm at Instagram, right? And if from Instagram, suppose I want to visit from Instagram, suppose I want to visit suppose I want to visit Spotify from Instagram, then what will happen? Then is it at 0 1 2, then 3, third position would be at 3 position. I need to update, right? I need to update at third position. What I need to update is, I need to update that it is Spotify now. But how can I delete all the, yeah, this is a problem, because all the, whenever I put Spotify here, then according to this, whenever I'm visiting any URL from a current page, it clears up all the forward history. I need to clear up Facebook and LinkedIn, right? So from a linked list point of view, if I just update next of Instagram, it will be Spotify, and it will be automatically cleared because Spotify's next is null. But how to clear from hash map? Because if I clear one by one, then that would take offline time, right? It would be the same problem. If I'm clearing one by one, then oh my god, what am I doing here? I cannot do anything. If it is 3, then 4 5 6 7 8 9 up to 100, it would be the same. I need to delete everything. Or is there any other way? Maybe I can mark. Oh, I need to charge my laptop. Maybe is there a way that I can mark that, okay, everything after this is still. I'm just charging my laptop, and it is already half an hour since I started. My friends are coming anytime soon, so I need to hurry up. Okay, I'm quite stuck here because of fan time. Oh my god, what should I do? Is there any way that I can mark, okay, everything from this, that all this is not a active value, you should ignore these values of and time. How to ignore those values? Because what was I doing here after Google? Okay, I was looking at this current, and so whenever I visit, then I can just say that I can just mark, right? I can just mark whenever visiting mark the current node as the latest as the end. You can say that this is the end of as the end. If I mark this as end, then I cannot go forward, that right? Okay, yeah, this is a good idea. So even if I'm going forward, then I will not go beyond that. Okay, good. Yeah, I think this is fine. I do not even need task map for that, right? I can just use array, isn't it? If I just use array and mark as in, then it would be a really simple solution. It would have been easy, not medium. So I'm just doubting I'm missing something. So let me do this again. So back and forward is over one time, that is fine. I would go forward until I meet the end, and I would go back until I meet the start. But whenever I'm visiting, then it will not take over n time, because whenever I'm inserting something, so suppose after Instagram, if I'm inserting Spotify, then like I said before, I just said that okay, since the current is at 2, so I would insert 3 is equal to Spotify, and then I would update that end is equal to 3, right? I would update current is equal to 3, and I would also update that end is equal to 3. So there will be Spotify, and this would be the end. This would be my end. Yeah, okay, I think this is a good idea. And that way I do not need to delete all the other values. I can just start from here only. So suppose if I want to visit from this, again if I want to visit Google from here, then I can just operate 4 is equal to Google. So even space complexity would also not be that, it will not be wasted as well. Let me just try array then. I think that I just understood the question completely and everything, because it seems like a really easy solution, simple solution. So I'm just doubtful that I missed something from the problem, or I missed some edge cases or something. But anyway, I think that due to time constraint, I'll just go forward with whatever I have in my hand, and I will think of the edge cases and null cases or everything later, which is not recommended. But yeah, today I'll do that. So browser history, so it means that I can just start an array, and in array I can just start home page, right? And whenever I'm visiting, then it means that if I'm visiting, this is what I should do, right? So current would also be current would be at 0 in the beginning. This is the current, and whenever I'm visiting, then it would be this is what I'm doing. So it would be array current plus 1 will be equal to URL, right? And I'd update current is equal to, but before doing this, what I should do is I should first of all check if there is if array dot length, because what I'm trying to say is that, because there might not be, because if array if I just array is equal to 1, then if I say that array 1 is equal to something value, then it would give me an error, right? Won't it? I can only push, I think, because this array is just of length 1. So if a is equal to 1, then a 0 1 1 will be equal to 2. Oh, it is not, it won't give me an error. Okay, that's fine then. So I can just do this only then, like directly, and array current plus 1 is equal to URL and end. Okay, current and I should also keep end, right? So in the beginning end will be equal to 1. Array end will be equal to 1. I'm getting messages from my friends, so okay, but I'll continue this. Array end is equal to so current, I need to operate current is equal to current plus 1. Current is equal to current plus plus, and yeah, and array end is also equal to current. Oh, I need to say this dot current, sorry, this dot current is equal to this dot current plus plus, and this dot current. Okay, I'll just say then current is equal to this dot current. Okay, that's fine. I can just do this dot current plus plus, so this dot current would be updated, and then right wherever I am, this would be updated, and current will be your new URL will be assigned to that current position, and that current position would be the array end whenever I'm visiting. That's it, and I'll nothing will be returned, it is null. So whenever I'm going back, then it means that back is the target position. So target position would be equal to, it will always be equal to this dot current minus steps, right? Isn't it? Suppose if I'm at 3, then if I'm going one step back, then it would be 3 minus 1 is equal to 2, so that's fine. And sometimes it might if it is less than 0, then I need to return. If it is less than 0, then I should say that the target position is 0, right? And I need to return this dot array. Oh, I should also write this dot array here, and here as well this dot array end, and I think here as well this dot array, this dot current, this dot array end. Okay, so I need to return this dot array current target position, and even in for forward I need to do the same thing. So this would be this dot current plus steps, and if target position is greater than end, this dot array end, then target position would be this dot target array end, right? So because I'm just saying that, okay, so here I can say that end is equal to 3, right? And suppose the current is at, suppose end is here, and suppose the current is at Google, then if the forward position is 2, then it would be 1 plus 2 is equal to 3. So I just return Spotify, but if forward step is equal to 3, then I would just return Spotify only. So yeah, if it is greater than this dot array, then I would return, then I'd have to equate this. I'm really doubtful that this would not work. In other cases I'd be so confident that this would work, but not today. Undefined. Oh no. This dot array. Oh, late. I cannot update a value that is a constant value. I assure that it will not work. Oh my god. What is expected and what is wrong? Then let's see. Oh, null, and face browser history, visit, back. Oh, okay. Oh yes, of course. I need to update current as well. Whatever, I need to update current value whenever I'm going back and forth. So this the target position is equal to this one, right? So I need to update this that current is equal to target position. No. Okay, it is not working in the beginning only. Oh, whenever. Okay, so browser history is null, and forward. So browser history, first of all, actually, guys, I should have thought all of these edge cases in the beginning, but this is not a good idea to just look at the wrong answer and then find out, okay, this is a edge case and I did not find it. But now I'm doing that. This is not good. So browser history, first of all, it is SPJN, and the second one is I'm moving forward 6 steps. So current will be at 0. Oh, end should be 0 in the beginning. Oh, that's what I was actually this was not even a edge case mistake. I did everything correctly. It was just a typo mistake. So after I code, I should have checked the checked, is everything correct as I wanted or not, because here also I intended to write 0 but I just mistakenly wrote 1, and somewhere all the typos mistakes. So it is a really good practice to look at the code at last to find out any typos or any any kind of errors which were not intended, and also to check conceptual logic, because if I checked if then this is conceptually correct code, then I would have found this uh, mistake as well. Let's look at the solution. I'm very curious. 2 stacks. Nice. Complexity analysis would be O of 1. Double linked list. Yeah, that was what I was thinking. But the time complexity would be, like I said, we insert a new node in our double link. It will take O of L time to create a new node if I'm visiting. But yeah, so this was the problem. So whenever I am going back and forward, then it would take O of mean of m comma n time, and we iterate on our double linked list nodes and stop when m nodes are iterated or when we reach the end. So that's what I was talking about as well. And a dynamic array. Okay, so this approach 3, I think that approach 3 is the best. So let's see what they are trying to do. I was also trying to create an array or something. What did they do? Just like linked list or dynamic array can also be used to simulate stack-like behavior. Just like previous approach, we can append elements at the end and use pointer to traverse the back and forth. So in our dynamic array, we can insert as many elements as we like. We can keep a pointer to point to the current URL, and instead of pointer to point the current URL, right? Like we used the current here. And instead of traversing back and forth, incrementing or decrementing pointer index like on the linked list, right? We can directly return the element at the respective index after making a jump of step elements, right? So this would implement. Okay, yeah, that's what I was trying to do as well. So if we use a linked list, then we had to traverse one by one, but when you use an array, then we can just directly jump there, and whenever we go back, we move our current pointer, right? And if we visit a new URL, we will insert the new element if we are at the end of the array, or override the next element with the new URL if we are not at the end. And similar to my solution, so we also use need to additional pointer to mark the right boundary in our array, right? So that was what I came up in at last only to mark the end. So they are saying that end as right boundary. So there is a right boundary. There's a possibility that more elements exist that overwritten element, but while doing forward operations, we should not visit those old elements, right? In reality, we should have deleted those elements, but instead we will use a pointer to stop iterating forward, as this will help us to save the time used in deleting those old elements, right? So if I'm just using old element, then it would take O of n time, right? Because whenever I inserted Spotify, then I need to delete all the elements, so it would take O of n time. That is why we are just using a right pointer, and we would know that okay, I cannot go past that, and so that would save us the time from deleting all the elements after that. Nice. Let me see the solution here. Okay, visited URLs, new array list, current URL, last URL, current URL, they're adding it, and like I did here, and if it is greater than current URL, then set URL will be this similar, quite similar. And back in the steps also it is the same, right? Oh, I could have done this in one line, so I could just add on math dot maximum of 0 comma, so even if this is negative, then if this goes to negative, then 0 will be returned, right? And even here also I could just use math dot minimum of, so minimum, this cannot go past array dot end, and then I could just return oh, I can just write, I don't even need to use a different line here. Let us see, this dot current, I don't even need to, I mean, create a different variable target position. So yeah, okay, this is my optimized code, I think, optimized and even better code. So I just use Math.max, and then I just return directly to this dot current. Okay, and time complexity is, we insert the URL string in our array and update current pointer, so it will of one time, this is also of one time. This is a long thing. Let's assume n visit calls are made. Okay, I think that I need to go right now because it's already 7:12. Thank you so much everyone for watching till now, watching up to this point, if you are watching, and I hope you have a great time ahead. Bye.